Greetings, dear students. Welcome to a new lesson on computer science for grade 10 and 11. In today's session, we will learn how software is created by following a series of steps called Program Development Life Cycle. We will focus on the different tasks carried out during each step and the tools that go along. To begin, let us start by looking at the contents of the lesson. We will first see what a program development life cycle is. Then we will learn about the different stages in a program development life cycle and the different tasks performed during each of those stages. After that, we will have a quiz to test your understanding of today's topic. And we will end today's session with a recap of the lesson. So, what is program development life cycle? First, let us see what we mean by program development. Program development refers to the creation of new software, and Program Development Life Cycle (PDLC) is a step-by-step method to create computer programs in any programming language. These steps are referred to as program development stages. The program development life cycle consists of 4 stages. The first stage is the analysis stage, followed by the design stage. Then comes the coding stage. The fourth and final stage is the testing stage. Usually, the outcome from one stage becomes the input for the following stage. This means that the outcome from analysis stage is used during the design stage. The outcome from the design stage is used during the coding stage, and so on. Two main tasks are carried out during the analysis stage. The first one is problem identification. During this stage, we need to understand and gather information about the problem that the new software is supposed to solve. The second stage is program specification. It is a detailed description of what the new software is expected to do to solve the problem. Two tools, or we can say two techniques, are used to carry out the tasks at the analysis stage. These are: first, abstraction. The developer uses abstraction to focus only on the important elements required to solve the problem and ignore the unnecessary details. The second tool is decomposition. Decomposition is used to break down a big complex task into smaller and simpler subtasks, which are easier to understand, hence easier to solve. Next comes the design stage. Two tasks are carried out during this stage. First, the problem is further decomposed, that is broken down into specific components. We will see what these components are in the next slide. Secondly, a design plan is produced. The design plan is a step-by-step plan to solve the problem, and it is drawn based on the program specification obtained from the analysis stage. A problem can be decomposed into the following four components. 1. Inputs. This consists of data that is put into the system by the user. Number 2. Processes. These are the steps that the system executes in order to solve a problem. Number 3. Outputs. These refer to results or data that is given back to the user by the system. Finally, number 4. Storage. It is any data or information that needs to be kept for future use or that will be used by another process. Three new tools are used during the design stage. These are structure diagrams. Structure diagrams are used to show how a big problem is broken down into smaller sub-problems and how the different parts work together. Secondly, we have flowcharts. A flowchart is a diagram showing the problem-solving steps using symbols, and arrows are used to show how to move between each step. Number 3 is pseudocode. Pseudocode is used to describe steps to solve a problem in simple English without using a specific programming language. Next is the coding stage. Two main tasks are performed in this stage. They are programming and iterative testing. Programming is done by programmers. They translate the design plan obtained from the design stage into program code using a programming language. Iterative testing refers to continuous testing as code is written. This means small subprograms are tested as soon as they are written instead of waiting until the whole program is completed. Iterative testing helps catch errors early in the stage. The last stage of the program development life cycle is a testing stage. In this stage, the completed program is tested by executing it several times. And each time, a different set of test data is used as input. Test data is needed to ensure that the program completes all parts of the solution without error. It also ensures that the results obtained from the program are correct and as expected. We learned what is program development life cycle and what are the different stages of a program development life cycle. We also learned about the tasks that are carried out during each stage and which tools are used to carry out these tasks. We are now going to have a quiz to assess how well you understood the lesson. The test will consist of different types of questions you may encounter in your assessments. Read the question carefully. You will have a few seconds to give your answer. Let us begin the quick test. The first question is a multiple choice question. Which of the following is not a stage of the program development life cycle? Option A, design. Option B, coding. Option C, decomposition. Or option D, testing. The correct answer is option C. Decomposition is not a stage of the program development life cycle. Decomposition is a tool used to break down a big problem into smaller sub-problems that are easier to understand. Question 2 is a matching question, a type of question which examiners use frequently. The question is, 4 tasks carried out during the program development life cycle stages are shown. Draw one line to link each task to its most appropriate program development life cycle stage. Note that not all program development life cycle stage will be used. Let us look at each task one by one. The first task is develop an algorithm to solve the problem by using structure diagrams, flowcharts, or pseudocode. If you recall correctly, this task is carried out during the design stage. The next task is detect and fix the errors in the program. Clearly, this refers to the testing stage. The task where we identify the problem and its requirements. This task is carried out during the analysis stage. The final task is write and implement the instructions to solve the problem. The word instruction hints us towards the coding stage. Note that evaluation as a stage has not been used as part of the answer. Question 3 requires you to tick correct answers. This is another common type of question in computer science question papers. Let us read it together. A program is being designed to allow passengers to buy their Metro Express tickets online. A list of information is given. Apply abstraction to indicate which item of information would be essential for the passenger when buying a ticket online. Tick one box in each row of the table below to show whether the information is essential or not essential. The first information available is travel date. It is important to know on which date the travel will take place before buying a ticket. Hence, travel date is an essential piece of information. The next information available is driver name. The name of the driver would not make any difference on ticket sale. Hence, it would not be an essential information. Train color. The train color is the next information to examine. Color of the train would not have any impact on ticket sale. Therefore, it is not essential. Next, we have departure station. Knowing where a travel starts is used to calculate the fare of the journey. Therefore, departure station would consist of an important and essential information when buying a ticket. Number of seats in a train. Since the number of passengers will keep changing from station to station, knowing the number of seats in a train is not an essential information when buying a ticket. Question 4. Name the 4 component parts of a problem after it has been decomposed. Let us look at a diagram that will help us identify the 4 components of a computer system. These are 1. Input, 2. Process, 3. Output, and 4. Storage. Question 5 is another question where you have to tick the correct answer. Tick one box to indicate the name of the diagram that shows how a big task is broken down into smaller subtasks. The choices are flowchart, pseudocode, structure chart, and subsystem. A flowchart, you will recall, is a diagram that uses symbols and arrows to show problem-solving steps, which is not what we are looking for. Pseudocode is used to write instruction in simple English without using any programming language. Again, not corresponding to the description given. The third option is structure chart. We saw earlier that it is a diagram that shows how a task is broken down into smaller tasks. Hence, this is a correct answer. The last option is also inappropriate as a subsystem is part of a structure diagram. It represents a smaller or simpler task. We come to the last question, which is a true-false question. Testing stage can only be started when the whole program is completed. True or false? The statement is false because using iterative testing, we can start testing part of a program instead of waiting until the whole program is completed. So that was the last question. I hope you were able to get all the correct answers. Before we end today's session, let us have a summary of what we learned on program development life cycle. Here comes the recap. In this lesson, we learned that program development life cycle is an organized way to create high-quality software. It consists of 4 stages. Stage 1 is the analysis stage. Tools like abstraction and decomposition are used to specify what a program does. Stage 2 is a design stage. Structure charts, flow charts, and pseudocode are used to show how the program should be developed. Stage 3 is a coding stage. During this stage, the software is developed using a programming language. Finally, stage 4 is a testing stage. The completed program is tested to make sure that it works as expected. Dear students, the recap brings us to the end of our journey through the program development life cycle and how software is made. Until we meet for a new lesson, I wish happy learning to everyone. Goodbye.